let's talk about the perfect heist. The thief never even gets near the vault. They don't pick a single lock, but they still walk away with all the money. So how did they do it? Well, they tricked a trusted insider into doing all the dirty work for them. Now, this isn't some movie plot. It's a very real web vulnerability. We're going to break down exactly how this digital heist works, and more importantly, how you can stop it.
So picture this. You're logged into your bank, just checking your balance. You open another tab, you click on what looks like a totally harmless link. Maybe a funny cat video, who knows? And then, bam, you get an alert. $1,000. Gone.
And here's the crazy part. You didn't type in your password. You didn't click confirm transfer. You didn't do anything. But from the bank's point of view, the request to send that money came straight from your browser, with your login credentials perfectly intact. To them, it looks completely legitimate.
Right, that is the million-dollar question, isn't it? If you didn't do it, and the bank is positive that you did, who's the real culprit here? Well, the answer lies in a really clever cyber attack that turns the one thing you trust the most, your own browser, against you.
This attack has a name, Cross-Site Request Forgery, or CSRF for short. It's a dangerous and honestly a pretty brilliant attack that forges a request from a malicious site, but it's crafted to look like it's coming from you, the trusted logged-in user.
Okay, so to understand how we defend against this, we first have to get to the bottom of the fundamental weakness that makes it all possible. And it all comes down to the way your browser handles authentication. The entire problem can be summed up in just 3 words. Cookies are sticky. Seriously, they are designed to automatically attach themselves to any request that's going back to the website that issued them. Now, this is great for convenience. You don't have to log in all the time, but oh boy, it is a nightmare for security.
This slide lays out the anatomy of the attack perfectly. Let's walk through it. Step 1. You log in, you get a session cookie. Totally normal. Step 2. You innocently visit a different website. Evil.com. That's the trap. Step 3 shows that Evil.com has some hidden code that sends a request back to your app. But Step 4, that's the betrayal. Your own browser sees the request is for mymurnapp.com, so it helpfully attaches your session cookie and sends it off. The result? Step 5, total disaster. Your server sees a valid request with a valid cookie and, poof, your account gets deleted.
And this right here brilliantly illustrates why this is so hard to stop. This is the problem from the server's perspective. On the left, you've got a real request coming from your application. On the right, you've got the forged one from evil.com. To the server, they look absolutely identical. Both have the correct endpoint, both have the valid session cookie. There is no way for the server to know that one of them is a trap.
So if the server can't tell the difference, how in the world do we stop this? Well, we need something extra. We need a piece of information that only our real application can know, but that the malicious site can't get its hands on. What we need is a secret handshake.
And this secret handshake is called a CSRF token. You can think of it as a random, secret code that the server generates and gives only to your legitimate front-end application. From then on, every time your app wants to do something important, it has to present this secret token to prove it's the real deal.
So how does this handshake actually work in practice? Let's look at the flow. Step 1, the server generates a random secret token. Step 2, it sends that token only to your legitimate application. Step 3 is the crucial part. Your app now has to include that token in a special header on every single request it makes. Now look at what happens to evil.com. Because of browser security rules, it can't read that token. It has no idea what it is. So when it tries to send its forged request, it's missing the secret, and as you see in Step 5, the server just rejects it flat out. The attack is stopped cold.
Okay, the theory is solid, but how do we actually put this into practice in a modern MERN stack? You know, MongoDB, Express, React, and Node. Well, it turns out we actually have 2 really powerful layers of defense we can use.
The first layer is fantastic because it's wonderfully simple and incredibly effective. It's a modern browser feature that's built right into cookies, and it's called the SameSite attribute. Think of this as your quick and easy first line of defense.
So in your Express backend code, right where you set your authentication cookie, you just add one line, SameSite, strict. This is a direct command to the browser. You're telling it, hey, if a request to my domain comes from a different domain, like evil.com, do not, under any circumstances, attach this cookie. This one single attribute stops the vast majority of CSRF attacks dead in their tracks.
But what if you're building an application that handles really sensitive financial data? Or it just requires the absolute highest level of security?
For that, we bring in our second layer, the full secret handshake implementation with CSRF tokens. This is the bank-grade fix.
Now, looking at the front-end code in your React app, the process is really straightforward. Step 1. When your app first loads, it just makes a quick request to a dedicated backend endpoint to get that unique token. Step 2. You then configure your API client, like Axios, to act as a little gatekeeper. As you can see, you just create an instance that automatically sticks that token into a header, like CSRF Token, for every single outgoing request. It's like an automated secret handshake. So, which defense should you be using? This slide breaks it down really nicely. For, I'd say, about 90% of applications out there, the SameSite cookie attribute provides strong, sufficient protection. It's easy and it's really effective. But if you're building a bank, a trading platform, anything with high-stakes data, you don't choose one or the other. You should implement both. Think of the SameSite attribute as your shield and the CSRF token as your vault door. Together, they offer the strongest security possible.
We've covered the threat, we've covered the flaw, and we've covered the fixes. So the most important part is, what do you need to do right now to protect your users? Let's just summarize it all with a final checklist.
First, always assume the browser can be tricked. Don't rely on it. Second, please go to your backend code and add SameSite strict to your session cookies today. It's such a simple change with a massive security impact. Third, if you handle sensitive data, you really do need to add a token-based strategy using a modern library. And most importantly, just remember that every single user login is an act of trust, and it's our job as developers to honor that trust.
And that really just leaves us with one final question to consider for every single application we build. This isn't just about code and cookies. It's about the faith that our users place in our work. So you have to ask yourself, is that trust secure?